test stacks today?
What was that?
We have a test stack?
No. No. I did not even look at it.
Hey, Vermont, did you know Spotify's not blocked right now? Really? Yeah, because I tried searching up the remix of the guy who was asleep right now. And it showed up, and I don't have it downloaded offline, so. So I was like, hey.
Hey Nick, Colton just told me to watch the Clarion Osage game and go to play 53.
Who's wrong catching the pass and just smoke through them? That's what it is. Who's running around the Sunny Hall showing up?
He
I
said
didn't go into the All-State thing though. I was like, I just had all this.
What?
Didn't tell him that you were out.
yeah.
I'm so scared. Like, I think you got this moment when I didn't go into the All-State.
No,
See,
I got her.
really
She's
felt
like,
this
so we were out there in the rain, like holding
Yeah.
her foot outside. I get in my way. She's
I literally was watching how it was. I just think so much.
Don't know.
Like, I think it's totally just like, she must have crushed her head out. Her boyfriend left her at the altar.
I was okay with it.
Just tell them that because, you know, right. That's what I'm doing.
Her mom came
Oh, you did? You're over here. Right here.
Oh my gosh.
Look at your knee. I look at your knee.
Look at it.
It didn't look at it. What is it?
I got you
What
good.
is it?
I got you.
What did you do? That's already started.
It's just
So we're gonna figure out
next to here. Does that show you a picture like what you're around?
Okay, I'm looking at you, and I can see over
Yeah, there's one online, there's one on the
your mom's
Hey. Okay. All right. We're gonna go through a couple things today. For Jack, if you want, you can scoot up. You don't have to sit way in the back. So you can scoot up. I think Cass I don't think Cass is here today. She can scoot up even further. So. All right. So all right. And Ethan's gone today. All right. So we're gonna hopefully get him back in Monday. Actually, I'm gonna promise you. All right. Okay. Here's what I'm gonna go through today. All right. I want to talk about the stuff we did not get yesterday because you guys had ASVABs. Period 9 got these notes, so we're gonna try to double up. Whatever I covered yesterday, I'm gonna cover with you today. Plus, we'll get a few extras. That's the stuff that the other classes will, I should say, period 9 will get today. Okay. So we are on section P.5. Okay, and just a reminder on this sections, we're only going to go 3 sections, like P5, P6, P7, and then we take another small quiz. It will not be 20 questions like the last one. It'll be significantly less since we only have 3 sections and there's only a few types of problems we have. It's not as broad as the last chapter. It gets more focused now.
When are we gonna know the scores of our...
Monday. So. Alright, oh, you mean your ASVAB?
No.
Your test? Yeah, you're gonna make Monday. So, alright, factoring. Okay, this is a big concept, right? Factoring is something that we will eventually do in every single homework, every single section. It just becomes a staple of like every problem that we're working on. It's just that you need to realize there is a bunch of different types of factoring, okay? And that's something that we just need practice on, the different types. Let's go through just a few of the different names. The main ones I want to make sure that we cover today: common factors. That's the first one. This is the one that you should always attempt to do first. Common factors is when you look at a problem and you notice that every item that's in your problem has something that they all share. So it could be a number, it could be a letter. So let me just give you a rough example here. Something like that. Right? When you're looking at that polynomial, right, it's actually a trinomial. There's 3 items there. What do you notice that they all have? A 5 in common. That's a common factor. So you try to rip the 5 off of each of them. That's what you do. And so we'll walk through that problem here in a minute. But you always attempt to do common factors first. The second type is the one that is more broad. There's a lot of different methods of doing it, but it's trinomials. Okay? I'm not the person that tries to have you memorize like the perfect trinomial square formula and this other formula, no. Just, I'm gonna teach you the simple method that I use, and it works for every trinomial that we have. We follow this one rule, it works each time, okay? Now, the other types, the ones that the other classes had not received yet. So this is hopefully we can, with you guys, we can at least see maybe one example of each. And we'll go maybe more in depth on Monday. The other topics that we need to discuss would be the difference of squares. Okay, what you'll find is that the difference of squares actually is the trinomial formula that I'm going to give you, like the method of how I do it. So it's not something that's new that you have to memorize. It just follows the same rules as before. So maybe that'll change your mind of what that problem looks like. Then one of the other rules is the cube rule. That rule, for some reason from previous years, is like the challenging one for people, the cube rule. Because I don't know if it's so much different than the others, or it's just the numbers are different. So I'll try to explain the best way I can for that, how I do it, like how I think of it every single time. Maybe that'll make sense to you. Try to do it my way, and then if that doesn't work for you, I'll try a different method. But I think you'll be fine once you see it. And then the last one is definitely the hardest out of the 5 to explain, because I can't prepare you for every problem with this last type, but I can at least give you the gist of it, like the main part of it, which is called grouping method. And that is by far the hardest to even attempt to explain, because every problem is different. But this is our goal. My goal for sure, like for sure, I want to get to the two in red, the top 2. We got to get through those 2 today to make sure that you're comfortable with those. And if we have a little bit of time, we'll try 1 or 2 of the last few. I don't know. If we don't get done, fine. We'll just carry to Monday. It's not a big deal. Okay, and we're not getting homework or anything like that because we just finished a test the other day, so we're not going to do that. Plus, you haven't even gotten back yet, so it's not fair. So, all right. Any questions, comments, concerns of what we're going to try to attempt today? Okay, now, if you're not quite getting this, I do have the video from yesterday, period 9s, because they went through some of the stuff. So you could watch that video if you wanted to, and you can kind of get like kind of a doubled up lesson. It's not important because I know you guys didn't even have class yesterday. So, but if you didn't like quite get it today, you could always go back and watch that too. So, all right. But let's first start with this common factors idea. I want to do at least 2 of these, because after you see 2, you'll be fine. Okay. So on this problem, what did you say that they all had in common? 5. So how factoring works, not foiling, not multiplying, factoring, is we are going back, we're taking this problem and we're going back to something where they are multiplying things together. That's what we're trying to go back to, right? Does that make sense, what factoring is? Going back to the original multiplication problem. Now for this problem, when you do common factors, this is what we're going back to. We're going back to one parenthesis, but we're going to have something outside of it. A scalar or an algebraic expression where there's just a variable out there. Because the thing that sits on the outside, when you multiply it back through, will turn back into this. That's what we want to go to. So this is kind of our goal. This is what we want to get to. That's what factoring is all about. So when you said in this problem, you guys said it was 5, right? That's what I'm going to pull on the outside. It's whatever they have in common. If they had letters, like all of them had a letter, you pull the letter out as well. Or if maybe it's just a letter, pull that out. Okay, so now, when you pull this item out, basically what you're doing is you're dividing each of these items by what you pulled out. That's what you're doing. You're dividing it off. Okay, now, my common sense rule before we start, this is just to make sure that you understand this before we even attempt this problem. You need to make sure that you count how many items are out here. How many items are there? 3? There should be 3 items in this parenthesis when you're done. I don't know why I need to preface that, but some people don't realize that. When there's 3 in the original problem, there should be 3 left in that parenthesis in the end. Okay? And I'll explain where somebody goes wrong. That'll be my next example. Alright, so we pulled a 5 out. So let's divide a 5 off of this thing. What am I left with? X cubed. Okay. Divide a 5 off of this. That's 3x. And divide a 5 off of that. Let's do. Okay. We good so far with that. Now what we would attempt, if you could go further, with that problem you'd attempt it. But this item, I know it's a trinomial, but the power's off. so I can't do this problem. That power of 3 really threw it off. If that was a power of 2, I could actually attempt to try to break that up even further, because this is something that it just doesn't work with power of 3. You can't do that type of problem. All right, any questions with common factors as of this moment? Okay, now I alluded at the fact that some people get this problem wrong, and it's because of this example I'm about to show you. So let's go with 16x squared y plus 12xy to the 5th plus 4x, no, yeah, and that's what we're going to talk about. Okay, so, and again, this can be any size. I just picked a trinomial. It doesn't matter. This could be a binomial. This could be something bigger. It could be, 15 items long. But what do you notice that they all have in common? 4, an x, and a y. Okay, because you're looking for each item that they all have. Okay, so you're trying to find the maximum number of items that they have. So they at least have the number 4, but then they have 1 x each, and they have 1 y each, at least. That's like the most that they all have. Alright, so when you take this 4xy out, you're dividing it out. That's what you're doing. So each of these items, so to get this first thing right here, I'm taking the 16x squared y, and I'm literally dividing by 4xy, because that's what I took out of it. So that's what you're doing. That's how I'm going to get this answer. Okay? So let's do that first. So 16 divided by 4 is 4. X squared divided by x. Yeah, because the x on the bottom goes away, you have to take 1 away from the top, so it'll be x left up there with the 4. And then the y's cancel out, so that's what you're left with. Plus sign. Now we do it again. So now we're doing the 12, right? Okay, so we'll just go right into it. So it's 3, the x is divided out, the y is divided to make 4 of them left over. Does that make sense? Like taking out the x and 1 of the y's? And then, yeah, in the very end, you have a plus 1, and that's the part people get wrong. They forget there is a plus 1 back there, because there was the 4xy, and you divided by 4xy out. So 4xy divided by 4xy is a 1, you have to leave it there. Because how many items do I start with? 3. There better be 3 in there. That's how it works. For some reason, people can't think of that. Okay. Are we comfortable with variables, common factors? Remember, I attempt this first. Every single problem, I attempt to do that. If it can't have common factors, then I resort to going to the other methods. Okay? And sometimes when you pull that item out, like this, when you pull out the 4xy, this may go further with the other rules. And so you have to check that. So far, the problems I made up don't. So. Alright, any questions, comments? Okay, good. So, let's move on to trinomials. We're going to spend probably a majority of the time today on those, just to make sure we know all the rules and all the little details of how to attempt those problems. Okay, so a trinomial. Like this. We're going to start easy, we'll work our way up to more difficult ones as we go. Why is that a trinomial? Let's start there.
It's got 3 terms.
3 terms. That's what trinomial means. There's 3 items there. The best news is I can actually factor this thing apart, even though it doesn't have common factors at all. The reason I know that is because it's in descending order. Correct descending order. That means there's no missing terms. If you go back to that first problem I did, I was missing the x squared term. So I knew I couldn't factor it apart. So, but I have every term here. I should be able to pull this thing apart. When you do trinomials, the first attempt you should try is if they have something in common. This one does not. So now you're going to the second rule, is where you're going to break this up into 2 parentheses. That's how trinomials normally work. You try to go into 2 parentheses. Okay? There'll be items in here. How many items will be in these parentheses? 2. It is actually a binomial that we're making these into. Binomial and a binomial. So there's going to be 2 items in each parenthesis. My goal today is to give you my simple rule, how this works, so that we get the same answer and you know how to do these problems every single time. Okay? The only difficult problems that I need to warn you of is when they put a number out front. When they put a number here. Now that problem is significantly harder. Way harder. Like, I don't even have a rule for that anymore. Because now it's just all trial and error. It just takes practice for how you do those. Okay? So, let's attempt to do this. So let's start with my basic set of rules, how I do these problems. So that way everyone's on the same page, you know how I attempt them, you know how I even start the problem. The first thing I do, make sure number one, you put it in descending order. If it's not, you rearrange. You need to. So that's step one, we're good. Second step, you look at the back symbol, which you know is totally goofy. Most people want to look at the numbers, look at the X's. I look at the back symbol. That back symbol tells me a lot. If it's a plus sign, like this, that means my symbols that are going to be in here are going to be the same operation. That's what it means. My symbols are growing like crazy. But they're going to be the same exact operation. Now, to know what the operation is, you have to look at what's in front of it. What's the operation up here? Positive. They're both going to be plus. They're both going to be positives. That's what that means. So, if you're doing the same problem, but now it's a minus sign, this means they're going to be the same. They're both going to be minus signs now. Because that's what the plus tells you. The operations in here are the same. They're both going to be negative signs. Okay? Yes. Alright. Okay. Okay, so are we good with that so far? The first rule, what I look at? Okay. So that's if it's a plus sign in the back. That tells me everything. Okay, so now that I know that they're both plus signs, now what I do is I break up this term. Where is that term found on your trinomial? It's in the first. You're going to break up that item and put it in the front of both parentheses. That's how it works. That's how I think of it. So how do you break up an x squared evenly? X and x. Now, if there was a number there, now it's significantly harder because now you have to break up the number and the variable, and I don't know the order you need to put it in anymore. There could be lots of options there. So we'll try it. We'll attempt one later. Okay, now that's the first item. The back item, the 4, is what you put in the back of both parentheses. So we have to break up the 4. You have multiple options. You have 1s and 4s or 2s and 2s. Because you're thinking of numbers that multiply to give you 4. So, how do you know which one to pick? Because you have options. You have to try to make the middle number now. So in this case, you are adding them together to make the middle, because it's both pluses. So, what operations for the 4s, or what number should I use for 4s? 4 and 1. Because that will make the 5 in the middle. And it does not matter where you put them. When the symbols are the same, it doesn't matter where you put the numbers. Okay? As long as you don't have a number up front, like in front of x squared. If there's a number up front, then it's a nightmare. Okay. Do the basic rules make sense to you? Let's apply it again. Let's do the same exact rules, but let's do it for a different problem. Okay? X squared minus 13x plus, let's go with 36. Okay, so what do we need to do first? What's my first rule?
Actually look at the signs.
Okay, let's look at the signs, right? It's in descending order, so we don't need to do anything with that, right? So we look at the signs. What is this telling me?
Same.
They're going to be the same. Both parentheses are going to be the same operations. So that's if we can do this wrong. Okay, they're going to be the same. So what are they both going to be? They're both going to be negatives. Because that's the symbol up front. So we have the rule now. Okay? For the x squared, we break up that evenly. So it's what? X and x. Okay, now we have to break up the item in the back, right? The 36. 36 has a lot of options. Okay, that's what makes this problem a little more difficult than the last one. 36 has 1 and 36, 2 and 18, 3 and 12, 4 and 9. We need to pick one of those options, if it works. And what, 6 and 6, you didn't do that one. I forgot all about that one. So, what numbers can you do that would multiply to give you 36, but will make 13? 4 and 9. And it doesn't matter where you put them. There you go. Okay, do we understand factoring right now. So far, trinomials. What I'm betting on is, I'm betting you did this a lot in Algebra 2. Okay, I know that. There's a reason. It's important. It is important. Now, I don't know how many times you did it or how many different types of problems you did, but it is important because in this class, this will be just become a normal thing we do in the middle of a problem. Because a lot of the times we're graphing here, or we're doing something where we're trying to find answers for a big problem. And maybe in that problem you have to do this. Because what we use factoring for, and especially graphing, is that if you were to attempt to graph this problem by hand, like looking at, like this is like a chart of sales for your company, and you're looking at a graph of it, what these numbers are, if this thing was equal to 0, okay, if you solve it, like you moved everything over, you're solving for 0, these numbers tell you when you neither have profit nor losses. That's what the numbers mean. So for this to work out to be equal to 0, one of these parentheses has to be 0. Because if that's 0, 0 times something is still 0. Or if this parentheses 0, 0 times some number, and that would give you 0. So there's two options. What would make this parentheses 0? A 4, positive 4, right? And what would make this parentheses 0? Or a positive 9, right? Well, when we graph, this is what it literally does. 1, 2, 3, 4, 5, 6, 7, 8, 9. We would cross 4 and 9, and this is what your chart would look like. And I'll explain why I know they're going up, and it's what these numbers are is this is where you would hit the x-axis. It's called an x-intercept number. That's why we factor. That's what we use it for. And so when you're in a company, you're looking at sales, you know where you're going to go into loss. Maybe you had to order products during this time period, so you had to spend a bunch of money to buy a bunch of new products, and then you went in the positive once you started selling them again. Okay, and eventually we'll figure out like where the minimum number is, like where the lowest point was. Those are things we learn in this class. Does that make sense? That's like one of our goals in like chapter 1, chapter 2 kind of thing. Okay, but we'll piece this together. Obviously you've not had to deal with this yet, maybe, but I'll walk you through that when we get there in chapter 1, because that's a big part of it. Okay? Because that's kind of the goal of this class, is to teach you how to solve difficult problems, to find the purpose of them. Okay, so, are we comfortable with that problem now? Okay, now let's attempt to do a different style of trinomial, but let's put the minus sign in the back now.
We'll put a number in front of the x.
And yeah, we'll do that one after this next one. Yep, we'll put a number up front. Okay, let's do a number with a minus sign here. Let's go with, okay. X squared plus 2x minus 63. Yeah, let's do that. Okay, it's still a trinomial, correct? First check, put it in descending order. Or there, good enough. Sometimes it might be easier just leaving it the way you have it. I'll explain that later, way later. But, alright, so we're here. So, what do we look at first? Yeah, the back sign, right? What is that telling us?
They're different.
Yeah. It's not a plus sign anymore, right? So it's not telling us that the operations in both parentheses are going to be the same. It's literally telling you that they're going to be opposites of each other. So I don't need to even look at what's out front. I don't care what's out front. I just know that they're automatically going to be opposites of each other because the minus sign in the back. If it was a plus, they have to be the same. But it's minus, they're automatically opposites. So now I break up the x squared evenly, x and x, so far, because I don't have any numbers up front, so that's kind of easy. And now we have to break up numbers for 63. Okay, 63 has a, 163, it has a 3 and 21, it has a 7 and 9, and then, yeah, so those are the options. But here's the problem. When the symbols are opposites, now it matters where you put them. It's not a free-for-all anymore. Because you gotta make the positive 2 in the middle. You gotta make positive 2 in the middle of that problem. So where do I need to put my numbers and what number should I pick?
9 on the left and 7 on the right.
Exactly. 9 for positive, 7 for negative. Because when you combine these, they eventually make positive 2. And then they also multiply to give you negative 63. Okay, any questions with that problem? Okay, I think that makes sense, right? The rules all apply when you have negatives and all that good stuff. I'm gonna leave it on the board because this type of problem will help us with difference of squares. That'll help us with the next time. But I wanna get to that problem because you guys are saying, what happens when you put a number out front? Okay, so let's do one of those problems. So, put a number out front. I'll try to keep it pretty basic. Let's go with, okay, 2x squared minus 24x minus, let's go with 60. Let's see, does that work? No, let's go with 90. 90 will work. Okay. So. Now this is a problem, right? Numbers are bigger, you've got different things going on. So, what should we do first? Okay, back sign, okay? So you're gonna do that. So you wanna work with back sign. What is the back sign telling you? Yeah, we're gonna automatically be plus minus, right? So now we're breaking up the 2x squared in the front. We're breaking up the 90 in the back. And we're trying to make this all work to give us 24. Ugh, that is definitely ugly, right? So I mean, it could be, geez, what do I do for that problem? It could be, 2x and 1x. I could put maybe 15 back here and a 6 up here. 6 times 15 is 90. And does that work? I have a negative 30, a positive 6. Yeah, that's it. Okay, so, okay, now, knowing how to do that, that's a nightmare, right? 90 is huge. You have a lot of options for 90. You have 1 and 90, 2 and 45. You have 3 and, geez, what is it? It's 3 and 30. You have, does 4 go into it? No. Does 6 goes into it, obviously, 6 and 15. What other options you have? You have 5 and 18. 9 and 10. You have a ton of options. Okay, you know what would have made this problem a lot easier to start with than doing that? Taking out the 2. Because now the numbers are smaller. Because what was the thing I always warned you of earlier? Common factors first. Now this problem would have been way more manageable. Because if I take out the 2, this is what you have. Now the problem is significantly easier. So I'm going to have, the minus sign in the back tells me it's automatically plus minus. I break up the x and x out front. I break up the 45 in the back, and I need to make a negative 12, so that would be your 3 and 15. 3 times 15 is 45, and that would give you negative 12 in the middle. It is still the same problem I just did a little bit ago. The only difference was I multiplied the 2 through to make 2x plus 6. That was the only difference. It's still the same problem. What you're looking at here, this problem, is said to be factored completely. The last problem wasn't. The last problem that I had, it was this. I had the 2x plus 6, the x minus 15. That problem is not factored completely because there's a 2 in common here. So you'd have to pull out the 2, and it would turn into this problem. It's easier if you pull out the number first, if it's possible. If it's not, because I'll make one where you can't, then you have to work with it until you can make the number in the middle. Question?
Are there 2 factorizations of that?
Yeah, because you could do the x plus 3, and then you could do the 2x minus 30. So, there's multiple options. But the trick is, if you do the factoring completely, take out the 2 first, there's only 1. It's this. Yeah, but yeah, I know. Because I know some people say, well, I factored that up, and I thought of it differently. You thought of it like this. 2x minus 30, and it still works, right? That's a negative, you know, it's a negative 90, there's still a negative 30, positive 6, it still worked out. It's just, if you factor out the 2, it's the same problem. Here's the bad part, what I need to warn you of. If you cannot pull out that 2 out front, like that, the common factor, I don't have a simple rule for you anymore. Now my simple rules, I can give you the signs to get the signs, whatever's in the parentheses. You know, I can tell you if you have something common or something, but the minute you can't pull out a number and you have to work that front number somehow, some reason, I can't help you anymore. Because now it's just trial and error, finding every combination of numbers that would possibly make the middle. And that just takes skill. That just takes pure skill and just multiplying. You just have to have really good multiplication facts.
Can we use the same problem, just put a 4 up front?
I can try, see if it works, something like that, yeah. So, yeah, let me make up a problem where it could possibly work. So, we'll go like 7x squared, I'll put a prime number up front so we know we can't break that up. 7x squared, we'll go minus, let's see, 6x plus, let's go at 45. Oh, I should make that minus. Okay, let's try this one, alright? Okay, so the trick is, can we pull out the 7?
No.
No, so that's the problem, right? It's not that common factor problem where it's that simple little rule where, well, 2 and now the problem's easy. Now it's just a trinomial that we just normally do. This problem's not. This is that one problem where it's, you can't pull out the 7 anymore. So, and the worst part is, I know it's gonna be plus minus sign. And that definitely makes it worse, because now it's not a free-for-all. It's very specific where you put the numbers, because I need to make a negative 6 in the middle. Somehow get to a negative 6 using a 7 and a 45. So typically what I do, this is just my little thing that I do. What I always do first is I just put 7x and 1x. I just throw those in there, because I can't do anything with it. So I just try that first. If it was like a 12 sitting there, you know, because I know 12 has numbers common, but if that was like a 12, I would attempt to just go like 6 and 2, or 3 and 4. I would just throw those numbers in there randomly, and see what happens. Okay, and then I would mix and match until I find the right combination. The 45, I'd break up 45. What are numbers that you know you could use with 45? 9 and 5, I would try those first, and I would just throw those in there. So I'll try 5 and 9, right? I would try this first and see if it works. If it doesn't, I'll try a different combination. Instead of using 5 and 9, I'll try a different number. Okay, or I'll switch the 9 and 5, maybe that'll make the difference. So let's try this out. So 7x squared, so this is just, I'm doing this in my head, 7x squared minus 35x plus 9x minus 45. Alright, will that make a negative 6 in the middle? No, so that's way too big. So if you switch it, if you switch the 9 and 5, you'll get even worse, right? Because this will give you like negative 63, that'll give you a positive 5, even worse. So that will not give you the 6 in the middle. So now, instead of using 9 and 5, let's try a different combination for 45. Let's try like 3 and 15. That should be the one, right? Because this will make 7x squared, make a negative 21x, positive 15x, and a negative 45. And that's the combination that makes negative 6, so this is how you factor it. And if that didn't work, I would try switching the 3 and 15 around. If that still isn't out, maybe I'll switch the negative positive sign around. Maybe that's the difference. So, I mean, there's no set rule, and that's the problem with these. It's kind of open-ended the minute they throw a leading coefficient out front. Okay, are we good so far on these problems? Okay, now. Let's talk about, I'm gonna go back to an easy one, because I mean, I do want to at least show you kind of the different rules that we can face. problems where they have multiple variables in them. It's still the same rule. The letters on the outsides are the ones that make the terms in the middle. So it's still the same rule. So I try the common factor first, nothing's in common. I try 2 parentheses where I look at the back symbol, it's telling me that they're both the same, they're both pluses, right? Because this tells me they're both pluses. I break up the x squared in the front, and then I'm going to break up the 2y squared in the back, right? How do you break up a 2y squared? 2y and a 1y? Yeah, 2y and a 1y. And that should make the 3 in the middle, which it does. Because when you FOIL it, you'll get, you know, x squared, 1xy, 2xy, and then a 2y squared. So yeah, it does make the 3 in the middle. So that's what you just need to realize. That's how you break it up. Some people, like, when they see the 2 variable thing, they like just shut off. They're like, oh god, it's 2 variables, not gonna do it. It's the same problem. They just threw an extra letter and you just put it in the back. Not a big deal. So you're just breaking up the first item, you're breaking up the back item. That's all you do. You're putting it front versus back. Question?
I'm just confused with the whole descending order thing. Wouldn't the y squared be next to the x squared?
Yeah, in that case, if it's like a trinomial like that, typically they go descending order by x's.
Okay.
So it'd be, you know, x squared, then 1x, and then no x's.
Okay.
That's how it works. Yeah, yeah, I understand what you're thinking of. But okay, any questions with that problem? I just wanted to let you see that. I know some people don't get to see that very often because I don't think we have too many problems that ever do that. But all right, let's talk about difference of squares. This might be my last problem today, just for you guys anyway. Difference of squares still follows the rules we just learned, okay, the trinomial rule. It does, and that's what I want to show you, because some people don't realize that. Okay, so let's do a difference of squares to talk about it. Now, to do difference of squares, you have to have the perfect square chart. That chart we talked about when we were doing the radicals the other day. So let me show you what a difference of square is. Okay, this is a difference of squares. It's a difference, there's a minus sign, right? So that means difference, and they are perfect squares sitting there. They both have to be perfect squares. This item and that item. And the variables are easy to see. Perfect squares, the letters have to be evens. That's fair enough. Now they have to be evens to be perfect squares. So 2, 4, 6, 8, 10, you know, that kind of thing. The numbers, you go to that perfect square chart. This chart that I gave you a long time ago. It has to be one of those numbers. Either the front, the back, it doesn't matter. I mean, I can put different combinations. I can put a 25 here, it doesn't really matter. As long as that they're both perfect square numbers, we're fine. I'll go back to this one. Okay, any questions so far on what it should look like? It's gotta be a binomial. That's the difference. Binomial, it's not a trinomial. But it still follows the trinomial rule, which I'll explain after I do this. So, when you do a difference of squares, this is how you're supposed to do it. You're supposed to make 2 parentheses. Put a plus minus sign in there. Okay, is that the rule that you're taught in Algebra 2? Okay. Then you break up the x squared first, which is x and x, and then you break up the 64, 8 and 8. Okay, that's what they teach you in Algebra 2. Has anyone ever figured out why they teach you that? Have they ever explained that, or did they just give you that rule? You just kind of got it, right? Okay, so that's how it usually works. I mean, that's how they even do it, like in Algebra 1. I know some schools teach this in Algebra 1. This really basic form of factoring. Here's the real reason why it's this. It's still a trinomial. It's a trinomial still. There's 3 items there. We're just missing the middle term. So, when you do a trinomial, we try to factor out anything in common. We don't have that. What's the back symbol? It's negative. When you do negatives in the back, what do you automatically have to have? Yeah, different symbols. You have to. That was the rule I just taught you. Okay? Then you break up the first item, x and x. You break up the back item. You have different options. 1 and 64, 2 and this, blah, blah, blah. But you have to make a 0 in the middle. What's the only combination that will give you 0? 8 and 8. Not zeros. But the only combination that will give you 8, when you combine them, you know, doing the normal combinations, will only be 8 and 8. Because the other combinations you know, if you did 64, it could be 1 and 64, 2 and what, 2 and 32, and you know, they wouldn't give you 0 in the middle. The only combination would be 8 and 8. This is why this works. That's why it works. It's still the trinomial rule. Okay, any questions with the difference of squares right now anyway? Okay, that's our last problem of the day, because we'll continue this concept tomorrow. We got through everything I wanted to today. We got through the top 2. Okay. But we're going to continue with these on Monday. Okay, we'll do a couple more examples of difference of squares, because obviously we're just starting it. Alright.
No.